So today we are continuing with quadratic equations. Then we shall go on and subsume roots of quadratic equations. That's what we want to look at. And under roots of quadratic equations, we are going to have two areas which we are going to concentrate on. Purposely today, we are going to start with the sum and products of quadratic equations. So we are going to look at sum. You can say sums and products. Sums and products. Sums and products of quadratic equations. So I want to look at sums and products of quadratic equations. So we are going to first consider our quadratic equation, which is in the form of ax squared plus bx plus c equals 0. Because we say that with quadratic equations, these are equations with the highest power of 2. And again, we say that the power must be a positive and not a negative. So consider an equation of the form ax squared plus bx plus c equals 0. And for this case, and I say that when you are dealing with a quadratic equation, make x squared to have a coefficient of 1. And how are we going to do that? The first step is look at our equation here. We are going to divide by a throughout, such that we can obtain a coefficient of 1 on x squared. So dividing both sides by a, Then I'm remaining with x squared plus b out of a, x plus c out of a equals 0. I can call this one as our first equation, which is having x squared having a coefficient of 1. We have tried to rearrange it in that way. Again, we say if alpha and beta are also roots of the equation, So we are now assuming here that if you have introduced other roots being given as alpha and beta, what do? We need now to form an equation which is in terms of alpha and beta. So we need to form a quadratic equation which is having the roots as alpha and beta. Like yesterday, what we did in the previous lesson, where we were forming equations when we were given roots which are there. So here we can start by saying let x equals these roots. You can say let x equals alpha. So when I bring this one here, it becomes x minus alpha equals 0. This one is the first equation. You can say maybe this equation star. Then also x equals beta. When I bring this one this side, it becomes also a negative. So I'm going to have x minus beta equals 0. I can say this is equation hash. Then from there, we are going to look at equation hash times equation star. Then we want to come out with such a kind of an equation which is in terms of alpha and beta. So we are following the same procedures like what we did when we were looking at how to form quadratic equations. So we are moving on, and these numbers are always common. Whenever any paper you choose it in for, you are going to find all these ones. It is principal maths paper 1. Even those ones who are doing subsidiary, it is also there. The same story is being applied there. So we can proceed with our ideas. You can say equation star times hash. We want to multiply those two equations. So the first one is x minus alpha into x minus beta equals 0 times 0, we are coming out with 0. So can we use layman's understanding so that we can go on and we open these brackets so that we can obtain our equation, which is in terms of alpha and beta. So can we go ahead? This is x into x minus beta, then minus alpha into x minus beta, the whole thing equals 0. So can we open together? X times x, we are coming out with x squared minus beta x minus alpha x. A negative times a negative, we are coming out with positive alpha beta equals a BL. Then from there, we collect like terms here. You can see x is common, so we are going to have x squared minus into, you can say alpha plus beta into x plus alpha beta, the whole thing equals 0. I can call this one is equation 2. Then at first we had equation 1. So we are going now to start comparing equation 1 with equation 2, such that we can come out with a certain stuff which we are trying to look for. You can go ahead and we divide our white board. So you can say comparing equation 1 with equation 2. So we're going to start comparing equation 1 with equation 2. You can say equation 1, we can first write them here. Equation 1 was x squared plus b out of a, x plus c out of a equals 0. This was equation 1. Then equation 2 is x squared minus alpha plus beta x plus alpha beta equals 0. This is the second equation. So we are now on the scenario of comparing. You can see x squared is the same as x squared. You can see negative alpha plus beta equals b out of a. These are what we call the sums. Then with the product I've got alpha beta equals c out of a. So we need now to start comparing those two. We are going to start saying sum equals sum. So I've got negative into alpha plus beta equals b out of a. So if we make alpha plus beta the subject, well, that means you're going to divide both sides by a negative. So we are having alpha plus beta equals negative b out of a, which is termed as the sum of roots. Sum of roots. So our sum of roots is given in terms of negative b over a. If yet is a positive, and I have already tried to prove for you where it has come from, if yet is a negative, automatically alpha plus beta will become a positive. And if it is x squared plus, and you are comparing, that means the sum of roots will automatically be a negative. It is not through gambling. I'm giving you the proof where it has come from. So again, comparing with now the products. This is the product and this is the product. So we shall say alpha beta equals c out of a, which is termed as the product of the roots. This is the product of the roots. So we are going to be following all these stuffs when we are calculating, when we are busy digging in too deep to look at the sum and the products of the roots, when you are given other roots, when they are also representing quadratic equations. So here we have got some useful identities which I want you to note. Some useful identities which you are going to be using. The first one is alpha squared plus beta squared is given as alpha plus beta, the whole of it squared, minus 2 alpha beta. This is 1. Then Roman 2 is alpha cubed plus beta cubed is the same as alpha plus beta cubed minus 3 alpha beta into alpha plus beta. Then another one is alpha minus beta, the whole of it squared is the same as alpha plus beta squared minus 4 alpha beta. Proof. I told you in A level, we don't just state everything. Here we are proving maturity. We are going now to derive all these ones where they came from. The idea in mind is we are going to be using the idea of the binomial expression where we could apply Pascal's triangle. So we are going to prove all these ones. After knowing all these ones, then we are going to start with the applicability of all these stuffs. So we can start with the proof for now, Roman 1. Alpha squared plus beta squared is the same as alpha plus beta squared minus 2 alpha beta. Where did it come from? So we are going to start from alpha plus beta squared. So we are starting with alpha plus beta squared. It means this one is appearing 2 times. How do we expand that one? This is the same as alpha plus beta, again into alpha plus beta. So we are going to use layman's understanding on how to open the two. The first one is alpha into alpha plus beta. Then here there is plus beta into alpha plus beta. So can we open the brackets? Alpha times alpha, what are we coming out with? We are coming with alpha squared plus alpha times beta. We are coming out with alpha beta plus beta times alpha is alpha beta plus beta times beta. We are coming out with a beta squared. Then from there we go ahead. Alpha, the squares, you can bring them close. So this is the same as alpha squared plus beta squared plus alpha beta plus alpha beta. What are you coming out with? We are coming out with 2 alpha beta, which is equal to alpha plus beta, the whole of it squared. So our mind is to make alpha squared plus beta squared the subject of the formula. Can you see here? This one is a positive. When it crosses an equal sign, automatically it becomes a negative. So we are going to have alpha plus beta squared minus 2 alpha beta, which is equal to alpha squared plus beta squared. So therefore, alpha squared plus beta squared is the same as alpha plus beta squared minus 2 alpha beta. So whenever you see alpha squared plus beta squared, just put this one as required. So I've tried to prove where it came from. I know where you are busy following me on this. So this one came through the expansion of that. So we are now going to prove the second identity before we take a small break. My emphasis is practice these ones, don't cram. Have them in your mind. Admire your work when you have proved it, then you will become perfect. So as we are taking a small break, we are going now to go to prove identity number 2 and identity number 3 as we go on.